In this video, we'll talk about Kepler's third law, this equation right here, and it's pretty fun once you get used to it, so let's check it out. In words, it says the square of the period. Period is just how long it takes a planet to orbit the sun. And as you can see, we're squaring it, so that's the left side of that equation there. T represents period. You could think of it like time. Okay, that's proportional to the cube to the power 3 of the semi-major axis. So that is what A stands for. But what the heck is that? Well, to visualize it, we have to draw an ellipse. And you could just think of it like a stretched out circle. If you go from one side of the ellipse to the other, that longest distance through the center is the major axis. Half of that is the semi-major axis. So it's comparable to the radius of a circle. We'll think of A as a radius. Okay, but is it fair to think of orbits for the planets as circles? Because they're all ellipses, right? Well, let's take a look at this table here. If the eccentricity of a planet is close to 0, then it's very circular in its orbit. Which planet is the most circular in its orbit? Venus, right? A close second by Neptune. On the other hand, if the eccentricity is close to 1, like for Halley's Comet, then it's very elliptical. So it's a nice, thin, stretched out circle. But even if we look at Mercury with 0.2, or yeah, we're definitely going to include Pluto in the mix, 0.25, even those two values are very circular for an eccentricity. So we can still use this for our model, no worries. All right, next board. What are we going to plug in for that A value there, that radius? Well, we're very self-centered, so of course it has to deal with Earth. It's going to be defined in terms of the distance from the sun to the Earth. That length there, that distance, is defined as 1 astronomical unit, or 1 AU. Notice this is the radius right here, so let's plug in 1 for A. 1 cubed, that's just going to give us 1. T squared equals 1. Well, T would also have to equal 1. And that all makes sense, because if T is 1, that means it's going to take 1 year to orbit at a radius of 1 or 1 AU, so it all fits. But we could answer a lot of other questions using this formula as well. For instance, how long does it take Mars to orbit the sun? All you need to know is how far away Mars is from the sun. So with a little help from Google, we find it's 1.524 AU. Let's add that into the diagram here. And of course, we got to add the red menace itself. Okay, now we're all set. Let's grab Kepler's formula here. This time we're going to change A to 1.524 right there. Let's do it. We're going to cube it, aka multiply by itself 3 times. That'll give us 3.54. Then we want to get T by itself, so we're going to square root both sides. Let's do that. And drum roll, Mars's orbit takes 1.88 years, almost double what it is on Earth. So as it goes around, it takes almost twice the time. However, it's not twice the distance. So that's where that formula holds that relationship together beautifully. Okay, here's another fun part. We can then convert this to days. Let's just multiply that by 365. That'll give us 687. Then, if you Google this question, feel free to do it. It's then going to give you 687 for its orbital period. So that's really satisfying part right there for me, at least, because it's like, yeah, we got your number, Mars. We know what you're up to. And here's one last look at the red menace. Okay, board 3. Feel free to pause if you just want to try this one on your own here. How long does it take Jupiter to orbit if it's 5.2 AU from the sun? So just a little over 5 times the distance that Earth is from the sun. Let's go ahead and grab Kepler's again, of course. Change A to 5.2. It's going to blow up a lot more when we cube it this time. It's going to blow up to 140.6. Square root, and take a guess in your head. Was it close to this, 11.9? That is how long it takes Jupiter to orbit. If we Google it, they just round it up a little bit, call it a nice even 12 right there. So as you can see, this formula is very powerful. Feel free to plug in any other planet, its distance away in AU, and find out how long it takes to orbit. But lastly, there's another way that you could use this formula. We could do the opposite and say, what if it takes 100 years to orbit? Then we could change t to 100, and then we could solve for A. So I leave that as a challenge for you to solve that. Find out how many AU away a planet would be if it takes 100 years to orbit. So I hope you got some good stuff out of this. Hope you found this helpful, and we'll see you in the next video. Toodles.